Yes, now we can discuss about tissue engineering, what it will do and what are the benefits we can discuss now. Tissue engineering is a biomedical engineering discipline that uses a combination of cells, engineering materials methods, and suitable biochemical and physiochemical factors to restore, maintain, improve, or replace different types of biological tissues. Tissue engineering often involves the use of cells placed on tissue scaffolds in the formation of new viable tissue for a medical purpose, but is not limited to applications involving cells and tissue scaffolds. While it was once categorized a subfield of biomaterials, having grown in scope and importance, it can be considered as a field in its own. While most definitions of tissue engineering cover a broad range of applications, in practice the term is closely associated with applications that repair or replace portions of or whole tissues, that is bone, cartilage, blood vessels, bladder, skin, muscle, etc. Often the tissues involved require certain mechanical and structural properties for proper functioning. The term has also been applied to effects to perform specific biochemical functions using cells within an artificially created support system. Example, an artificial pancreas or a bio-artificial liver. The term regenerative medicine is often used synonymously with tissue engineering, although those involved in regenerating medicine place more emphasis on the use of stem cells or progenitor cells to produce tissues. Overview: a commonly applied definition of tissue engineering, as stated by Langer and Vacanti, is an interdisciplinary field that applies the principles of engineering and life sciences toward the development of biological substitutes that restore, maintain, or improve biological tissue function or a whole organ. In addition, Langer and Vacanti also state that there are three main types of tissue engineering: cells, tissue inducing substances, and a cells plus matrix approach, often referred to as a scaffold. Tissue engineering has also been defined as understanding the principles of tissue growth and applying this to produce functional replacement tissue for clinical use. A further description goes on to say that an underlying supposition of tissue engineering is that the employment of natural biology of the system will allow for greater success in developing therapeutic strategies aimed at the replacement, repair, maintenance, or enhancement of tissue function. Developments in the multidisciplinary field of tissue engineering have yielded a novel set of tissue replacement parts and implementation strategies. Scientific advances in biomaterials, stem cells, growth and differentiation factors, and biomimetic environments have created unique opportunities to affordable and fabricate or improve existing tissues in the laboratory for combinations of engineered extracellular matrix, scaffolds, cells, and biologically active molecules. I am also preparing the notes to explain all these things without missing options, so that I am also preparing the notes. By that notes only I am explaining to you. Among the major challenges now facing tissue engineering is the need for more complex functionality, biomechanical stability, and vascularization in laboratory grown tissues destined for transplantation, The continued success of tissue engineering and the eventual development of true human replacement parts will grow from the convergence of engineering and basic research advances in tissue, matrix, growth factor, stem cell and development biology, as well as materials science and bioinformatics. Etymology. The historic origins of the term are unclear, as the definition of the word has changed throughout the past decades. The term first appeared in 1984, the year. Application that described the organization of an endothelium like membrane on the surface of a long implanted synthetic ophthalmic prosthesis. This is the information regarding to tissue engineering. Tissue engineering is also very advanced, and it is very useful to so many operations in medical technologies and all these. So we can welcome this, and it will be useful in so many ways. So it is a scope we want to give by this YouTube video. I want to give a scope to startup companies also to understand what is tissue engineering, what are the further steps we can take for new technologies, and the benefits and uses of tissue engineering. Likewise, it will give very good prosperity to the human beings, and tissue engineering will be highly useful in almost all fields also, so that it will give very good prosperity, and it is prosperous to everyone also. Wishing you all the best. May God bless.